Namaste. Welcome to the next video. In this video, we'll study taxonomy of machine learning techniques. Machine learning techniques can be categorized based on the following criteria. Based on the labels, models, and learning styles. There are two broad categories of machine learning models, supervised and unsupervised, that we'll study in our course. There are additional two categories which are semi-supervised learning and reinforcement learning, which will not be covered in this course. So the supervised and unsupervised learning is defined based on presence or absence of label. So in some sense, supervised and unsupervised classification is based on labels. So if the label is present, we have a supervised learning technique. If the label is absent, we have unsupervised learning technique. And label is present in the training set. Within supervised learning techniques, there are again two classes based on the type of the label. If the label is a real number, then we have a regression problem, and if label is a discrete quantity from certain set, we have a classification problem at hand. So in the regression problem, we may have a single output label or multiple label. Based on that, there are further classification of the regression. This is a single label regression and multi-label regression or multi-output regression. In the same manner, there are further classification within the classification tab. So single label classification and multi-label classification. Within single label classification, there could be just two labels, positive or negative, or 0, 1, or yes, no. So if there are two labels, it's called as binary class classification or binary classification. If there are more than two labels that are present, we call it as a multi-class classification problem. In the multi-label setting, where there are more than one label associated with every training example. So multi-label could be a binary multi-label, or it could be multi-class multi-label problem. Again, in binary, there are just two classes that are present, and in multi-class, there are more than two classes that are present. Looking at the second branch of machine learning algorithms, where label is not present, those are called as unsupervised learning techniques. And there are two main categories. One is clustering and second is rule learning. Rule learning is something that won't be covered in this course. We'll be talking about clustering. So let's recap. Based on the presence or absence of a label, machine learning techniques are divided into two types. Supervised learning techniques where labels are present, and unsupervised learning techniques where labels are not present or labels are absent. The supervised techniques are again divided into two types: regression, where the label is a real number, and classification, where the label is a discrete quantity from some finite set. Based on the number of labels, we get further division as single label, where there is a single label that is present, or multi-label. So we have multi-label classification or regression problem. In case of regression, it is called as multi-output regression problem. Based on the number of labels in the label class, we have a binary classification problem where there are just two labels present in the label class, or a multi-class problem where there are more than two labels present in the label class. Let's look at some of the examples of each of these types. So let's look at the example of a single label regression. Prediction of a price of a house based on its characteristics is an instance of a single label regression problem, because we want a single number as an output, which is a real number, and that is the price of the house. What is the example of multi-output regression? So prediction of stock price for next 5 days, right? So here we are going to predict multiple numbers, which is the price of the stock for next 5 days. So there are 5 different outputs and all of them are real numbers. So this is an example of multi-output regression problem. Let's look at the example of a single label classification problem. So if an online transaction is a fraudulent or not, so prediction of that is an example of a single label classification. Say you are doing a transaction on payment apps like Google Pay or Phone Pay, and if Google Pay or Phone Pay wants to determine whether your transaction is genuine or not, or whether it's a fraudulent or not. So there are two possibilities: either transaction is fraudulent or not fraudulent. So this is an example of a single label binary classification, because there are exactly two labels in the label class, and each transaction gets a single label, which is whether it's a fraudulent transaction or a genuine transaction. So that's why it's a single label binary classification problem. Let's imagine another situation where, let's say, you are given an image and you are asked to label all fruits in the image. Now we are talking about labeling all fruits, so hence the output will be multiple. There will be multiple possible fruits in an image, so we have a multi-label classification problem over here. Hope these examples have made it a bit clearer how the classification of machine learning techniques has been done. So that was for label-based taxonomy. Let's look at the model-based taxonomy. So model-based taxonomy, the base of it is the type of machine learning model, right? So there are again different type of machine learning models. So there are two broad categories. One is instance-based and second is model-based. So we have an example of k nearest neighbor as an instance-based classifier, and we have model-based classification. There are further two types. One is generative model and second is discriminative model. We are going to cover most of these algorithms. So we are going to cover k nearest neighbor, which is an instance-based classification algorithm, then naive-based classifier, which is the generative model, and logistic regression, SVM, decision tree, perceptron, deep neural network. These are all discriminative models. So we are going to cover all of them. Only two models that will not be covered in this course are hidden Markov model and Markov random field, which is mentioned on this slide. Okay. So let's look at further into model-based technique. So the model-based techniques, you know what the model does, right? Model learns the mapping between feature and the labels, right? So and model is defined by a concrete mathematical function or a formula, right? So there are two types of models. One is the generative model and discriminative model. In case of generative model, they use probability distribution for modeling the underlying data generation process, and then learn the parameter of the distribution based on the training examples, right? So this is slightly different. Instead of having a formula that we saw in case of, let's say, linear model, here generative models assume that there is some underlying data generation process from which the training data is getting generated. And what they do is they assume some kind of a probability distribution and then learn the parameters of the distribution based on the training set. Some of the examples of generative models are naive-based classifier, hidden Markov model, and Markov random field. We'll be covering naive-based classifier in this course. Then we have discriminative models. Discriminative models don't care about data generation process so much, but they learn the separator between classes. So instead of learning underlying data distribution, they just learn the separator between the classes. And for any new example, they try to figure out whether the example lies on which side of the decision boundary or the separator. Some of the examples include logistic regression, SVM, decision trees, and neural networks. And all of these examples or all of these models will be covered in our course. Finally, we have instance-based techniques. So instance-based techniques do not try to do any modeling, but they just store all the examples, and whenever a test example comes in, they compare that test example with every training example with some notion of similarity that could be based on some distance functions or some other kind of similarities, and based on that they assign the label to the test example based on the nearest training examples. So one of the example of that is a k nearest neighbor classification or regression, which we will be covering in our course. Finally, we have learning style based taxonomy, and based on learning styles there are two types. One is batch learning and second is online learning. So batch learning and online learning depends on the way we run the optimization procedure, and we'll be covering them in detail later in this course. In case of unsupervised learning, where the label is not present, We have two types, clustering and rule learning, and we'll be covering clustering in detail in this course. That's it from the machine learning taxonomy. Hope you enjoyed the video. See you in the next video. Namaste.